This is activity 15-2, find all three. And in this activity, each student gets a card. So here's a bunch of cards that get cut out. Each student gets a single card. And on that card, you're supposed to figure out what the angles are of the triangle. And in this case, you know that that angle is 90 degrees. So how would you figure out what this angle is? And how would you figure out what this angle is? Well, I thought that was pretty tough to do. And so what I did is I actually went through some thinking, and that's what I'm going to do in this video. And I would suggest that as students, you go through the same thing. You get a blank card, and I put these into my Google Drive for you. And you go through the same thinking after you study what I've done. And you don't have to do it exactly the way I do it. You can use your own thinking. That's the idea. But the idea is to practice, to go through and practice looking at the angles and making some logical choices or reason through why you think those angles are the size that they are. So for example, this first card is 90 degrees. And then actually, I'm sorry, once you do that, you're supposed to go around the classroom and find somebody that has a different card, but a congruent triangle, meaning that they are exactly the same. They're just different angles are labeled, and they might be rotated in a different way. So if I were looking at this triangle, now granted, I know the answer, so I'm cheating here for a bit, but it's still good to go through the logic. So this is 90 degrees, and it is not an isosceles right triangle. This side right here is a little bit longer than this side. We learned from the last lesson that if you lengthen this side, this angle gets smaller and smaller and smaller. If it were an isosceles right triangle, this angle would be 45 degrees. Since it's not, it's a little bit longer. This angle is going to be a little bit less than 45 degrees. And likewise, this side is shorter, so this angle is going to be a little bit greater than 45 degrees. Well, add 5 degrees to 45, this becomes 50. Take 5 degrees away from 45, this becomes 40, and those would be pretty good guesses because these angles are both pretty close to 45 degrees, and as I just mentioned, I already know that's the answer, but it makes sense. The logic then begins to make sense. So if you practice going through that, saying the same things, telling yourself the same stuff, maybe going through it with another person, you'll start to understand the reasoning. Let's go to the next one. This is not labeled in this case, but this is a 40-degree angle. They're giving you that. This side's a little bit longer. That means that this angle is a little bit smaller than this angle up here. This angle is a little bit shorter. Now, if you're not sure of that, imagine making this side shorter and shorter and shorter, say right here, and then think about how large this angle would be. It's getting bigger and bigger, larger and larger as you make it shorter. So this angle is 40 degrees. This angle is going to be larger than that. Well, if you know that this angle is 90 degrees, and the other thing to get from this activity is to further understand that the sum of the angles of a triangle equal 180 degrees. They always add to 180 degrees. That means that what you have left over, this is 90 degrees. These two angles have to equal 90 degrees, so this angle is 50 degrees. And the third card actually shows you that. This is the shorter side. This is 50 degrees. This is 90 degrees. And using the same reasoning, this is going to be 40 degrees. This side is longer. Angle is smaller. This side is shorter. This angle is larger. Okay, the next set. You're given this angle as 120 degrees. Now, if this were an isosceles triangle, now it's an obtuse triangle because this is larger than 90 degrees. And if it were an isosceles triangle, then you have 60 degrees left because remember they have to add to 180 degrees. That means that you could split that 60 degrees into 30 degrees and 30 degrees. Well, this angle is a little bit larger than 30 degrees. This angle is a little bit smaller than 30 degrees. So you just kind of make a guess. So 30 plus add 10 to it. That would be 40 degrees. 30 minus 10 is going to be 20 degrees. And again, I know the answer, so I know I'm cheating a little bit, but that's the reasoning that you would go through. And it turns out that that is the correct answer. So this is 20 degrees. If you reason through, this is larger than 90 degrees. And you might be looking at other people's cards and realizing, oh, there has to be a 120-degree angle there. So this is going to be 40 degrees. And so you have 120 degrees left over. So then remember, the sum of these three angles have to equal 180 degrees. And you might look at this angle here, draw a right angle. So this is 90 degrees. And then how much do you think's left over? How big do you think that angle is? Well, this is kind of tough. I think this is hard to see, but this angle is a little bit smaller than this angle. So this angle is going to be 30 degrees more than 90, so it's 120 degrees. And this angle is 40 degrees. All right, so they're giving you this angle is 40 degrees. This is that large obtuse angle. Actually, it's not that large. It's just a bit bigger than 90 degrees. This is 120 degrees. They have to add to 180. So this has to be 20 degrees down here. Just confirms that thinking a little bit. So 60 degrees is left over. If it were an isosceles triangle, you got to reason that this is 120 degrees. This one's kind of tough. This is tough. All right, 3a. This is an acute triangle, and it's a scalene triangle. So you have three acute angles, all less than 90 degrees, and different lengths. So first of all, if you look at this, this is almost, let's see, they're telling you that this is 40 degrees. This is a longer side than this side. So this angle is going to be less than this angle. And let's see, add to 140 degrees. So if this is 40 degrees, then what's left over has to add to 140 degrees, because 140 plus 40 is 180. All right, this gets a little bit tough, but half of 140 is 70. So if this were an isosceles triangle, this would be 70 degrees, and this would be 70 degrees. Well, this angle is a little bit more, almost 90 degrees, and this angle is a little bit less. So you take that 70 degrees, take 10 degrees off, and that goes here. This is 60 degrees. Take that same 70 degrees, add 10 degrees to it, and this is going to be bumped up to 80 degrees. So a little bit less than 90. So here's the right angle. That would be 90. And again, I know the answer, and I'm just going through the logic of how one way to think about it. So this is 40 degrees. This is 60 degrees, so it's larger than the 40 degrees. This length is less. It's going to make this angle larger. And this angle is the largest of the three. This angle is 80 degrees. This is kind of tough. So they're giving you this is 80 degrees, and what's left has to add to 100. So if you divide that 100 in half, this would be 50 and 50. This angle is a little bit larger, so give this angle 10 degrees. Take off 10 degrees from 50. This becomes 60 and 40. So you might compare this card with the previous card and go through the thinking and see how you can come to the same conclusions. And this is a 60-degree angle. Again, the same idea. What's left is 120 degrees. Half of 120 is 60. But this is quite a bit smaller than 60, so you might take the 20 degrees off. Might make sense. This is adding 20 degrees to 60. It's almost 90 degrees. So it makes sense that this would be 80 degrees. This arrow here must be that I guess that this was 80 degrees. It's larger than this. So that makes this 140 degrees. And that makes the 40 degrees left over. All right, the last two are a little bit easier because they're isosceles triangles. So you have to recognize that they are isosceles triangles. If that's true, then this angle is the same as this angle. You got to recognize that these two angles are equal. This one's a little bit larger. These two sides are equal. So that makes this a 50-degree angle. Well, if that's 50 degrees, 100 degrees is used. That means you have 80 degrees left over. So this angle up here has to be 80 degrees. And we've had 80 degrees in some of the previous cards, and so you're starting to get used to what 80 degrees looks like. And that's one of the ideas of this activity. What do these angles look like? What's the measure of these angles just by looking at them? So you get an idea of a 60-degree angle, and this is a 50-degree angle, and we've worked with 45-degree angles, so it makes sense that that's about 50 degrees. Same reasoning, isosceles triangle, that makes this 50, that makes this 80. All right, again, same idea. If this is an isosceles triangle, 100 degrees remains. So this is 80 degrees. 180 minus 80 means 100 degrees remains. That means that 50 degrees, 100 degrees is going to be split up between 50 and 50. This is an isosceles triangle. Once you recognize it's an isosceles triangle, your task becomes easier. And the last one, once again, this is an isosceles triangle as well. A large angle, 140 degrees. What's left over is 40 degrees, so it's 20 degrees here, 20 degrees here. That 40 degrees gets divided by 2, so 20 and 20. Same idea, recognize that this is an isosceles triangle, so if they're telling you this is 20 degrees, then this has to be 20 degrees. You have 140 degrees left, which has to be the size of this angle right here. And the very last card, again, recognizing this isosceles triangle, 20 degrees, 20 degrees. That's using up 40 degrees. That means you have 140 degrees left. And you could play around and make a right angle here. And then that remaining angle then has to be 50 degrees. Does that make sense? Does it look like a 50-degree angle? Again, that's one of the ideas of this activity, is to get used to looking at the different angles and guessing or estimating what their size is based on your past experience. All right, so find all three angles. One of the main points is that the three angles of a triangle add to 180 degrees.